Hello, everybody. I'm Nick, and in this video, no, not today, not today. How's everyone doing? I hope you're not too tired. I know it's been a long day, many great talks. I was in Rachel's keynote. Excellent. I want to address something on that in a second. It's my last time, or my second time here, actually. I was here last year running a workshop and doing a talk. And I'm back this year because I really liked the weather. Which changed from summer to winter to now summer again. And I'm here to talk to you about something that I think all of us are doing, and that is logging. Well, I hope all of us are doing logging, because if you're building software, you have to maintain it, you have to debug it, you have to somehow fix it. Now, just a quick introduction. Hi, my name is Nick Chapsas. If you know me from YouTube. That's why that joke I did in the bit was funny. If you don't know me from YouTube, that wasn't funny. And I'm a bunch of things. I'm Microsoft MVP, blah, blah, blah. I have a podcast, which you might want to follow. And I am a course author on my own website, nickchapsas.com, which will be soon rebranded to something else. So keep an eye out if you want to take your career to the next level in several topics in .NET, like dependency injection, minimal APIs, REST APIs, and so on. Give it a go. Or talk to your companies to buy stuff. Cool. So I want to take a moment to address the title, because, like, seriously, you're doing logging wrong. Let's fix it. Like, okay, Nick, have you seriously seen my code and you know that I'm doing it wrong? How can you assume that? That sounds like clickbait. And it is. Largely it is. In fact, when Rachel this morning was on stage and she's like, oh, and then clickbait articles on the internet, I thought that this would happen. But, I mean, look, there's good clickbait and there's bad clickbait. Hopefully, you'll find this title good clickbait, because we are all here to learn. But one thing you need to know about clickbait is that it actually does work. So, don't blame the player, blame the game. So let's talk about logging. And I want to know something. How many of you are logging in your applications? In any way, anywhere? Yeah, so everyone. This applies to everyone. If anyone didn't raise their hand, what the hell? Get on it. But I need to make something extremely clear. This talk is not about any of this. So whether you're pushing your logs into Loggly, Sec, CloudWatch, App Insights, Datadog, whatever the hell Google has in their cloud, nobody's using that. Anyone using GCP here? Sorry. I don't even think it's real. This is what this is all about. If you've ever written a line of code like this, that's what this talk is about. Now, we will talk about the implications of pushing your code into something, or your logs into something like Application Insights or CloudWatch, but fundamentally, it is about the C#. But I also have to take a step back and address something that I might be a bit guilty of, but you'll see. It will certainly, at times, especially in the first half, feel like this, where I'm trying to disguise a logging talk or a performance talk as a logging talk. Trust me, that is not the case. In fact, everything we're going to see here is really not opinionated. There's no, oh, Jimmy thinks that's how it should be done, but Michael thinks that's how it should be done, and then Nick thinks that's how it should be done, so we're going to choose Nick or whatever. This is about doing the thing right, and there's really only one right way in this situation. So don't fight me. Ultimately, it is about the real world. Now, I want to have a theme. I like to have a theme in my talks which weaves through all the slides. And I want to start with a very simple question. What is this? Now, I don't expect an answer, because this will be very awkward if you all start saying what you think it is. But I'm going to be a bit more specific. What is this? What is this supposed to be? The hello there. The message? In fact, if I'm using rider as my ID because I prefer it over the alternatives. If I use the hold control to show hint, which is the name of the parameter for this field, and by the way, this is using the built-in Microsoft logger, you're going to see that this is called message. It isn't. This is the message template. So let's start with the theme, which is going to be Nick's 7 logging rules. Rule number 1, the message is actually the message template, and it shall be treated as one. It started as something else. It was changed. Microsoft is really bad at naming things. I know John is here, so sorry. But fake news. But the message should be treated as a message template. And most of what is being done wrong is based on this. I've seen something along those lines based on that idea that the message you're trying to push in is not treated how it should be, and it leads to crucial performance issues and crucial business-oriented issues. So if you're doing any of this, string interpolation, string concatenation, string formatting, all of these are wrong. I would normally ask how many of you do any of this, but normally people don't raise their hand. Okay, you seem keen. How many of you have written code with any of these? Jesus Christ. What the hell? Okay, you're going to learn today. See how the title was accurate? By the way, for the record, I've written code like this. And I'm going to start explaining why these are wrong, by explaining what is my personal favorite thing of being wrong in this situation, which I think most of you are doing the same mistake, which is string interpolation. Now, a bit of a history time, and at times as I'm going through this section, you're going to be like, he said this talk is about logging. It is, trust me. So, what is string interpolation? Well, back in the day, if you wanted to have a string that has some parameters like Nick, which just turned 30 years old, which I did, thank you very much for the happy birthdays, you would have something like this, where you have a user and then double quotes, plus, name, turned, whatever. Fun fact, this is still how Java does things today. Anyway, that thing, however, like most of C#'s features, are actually lowered or converted during the lowering process to a string.concat invocation. So really, string concatenation is being compiled like an invocation of that method. You will see why that makes sense in a second. There's an alternative, which is the other way that Java does things, which is a string.format method. So you can have a user, you can say, I have position 0 and position 1. I'm going to pass those parameters in name and age. However, in C#6, if I'm not wrong, which I don't think I am, we got this, which is string interpolation. All you need to do is have this very nice $sign in the beginning, and then angle brackets, name, age, which hopefully you will agree with me, it's very nice, way better than what we had before. But one thing you have to know about C# is that the way it's been built and shipped in the CLR for years has been very defensively because of how .NET was historically shipped into machines, and you couldn't really patch it per se. That's why we got some service packs in the past to have some updates on a few of the things that run around machines. So what you need to know is that when they add the new feature, the way to add that feature is with a technique called syntactic sugar. So everything but the brand new C#11 static abstract members on interfaces and generic attributes were actually lower C# features or low-level C# from high-level C#. And string interpolation is no different. Until C#10, string interpolation was actually this. You had the top code being converted to string.format. Now, why is that important? Well, it has to do with the string.format method, sorry, and it has to do with the string.concat method. And both of them suffer from the same issue. Can you spot it? I'll help you. Whenever you see a parameters or an object array in general, nullable or not, know that this is a performance trap that you can fall into. Sometimes it is necessary evil. You can't really not use it, but you can minimize it as much as possible. But in order to understand why that's problematic, I have to take another step back, and talk about how C# deals with memory. I promise this is a logging talk. So C# allocates memory in two different locations, the stack and the heap. Whoa, Nick. OK, what the hell is a stack and the heap? Let's take another step back. The stack is a very nice place. It is local to methods like this. So we don't have to deal with things like garbage collection or reference types or stuff outside of our control. When you have an integer, or when you have an ID, which is a GUID, which is a struct, which is a value type, or if you have this point to D, which in this case, it is a struct, then in that context, all of these things will actually be allocated local to this method on the stack. You won't have to put them on the heap, which is the expensive side of things. Now, by the way, for those of you who really know your memory stuff, there's actually one more thing allocated here on the stack, which has to do with the type of the point. Don't worry about it. The other area where you can allocate memory, it is actually the heap. And the heap is the bad one. In fact, every time you see a slide from Microsoft saying .NET is 11 billion times faster than Node.js, very accurate and non-biased graph, by the way, you're going to see that the reason why they managed to break down so much to such great performance is that they removed heap allocations. And if you follow performance in .NET, you know that the usage of structures like span, for example, had the biggest impact on that. In fact, if you do follow my podcast, which, by the way, Keep Coding podcast, I had recently Stephen Tobe, great performance-oriented person in .NET, and he explained how that was the case. Now, in this case, assume that both person and point2D are reference types. They are classes, not structs. If that is the case, how C# is actually going to work is it is going to use the heap, this sort of floating bubble of memory, if you may, and it's going to give an address on each allocation, put that thing there somewhere where it can fit, and then keep effectively an address to that location, a key. Imagine it as a key and sort of value pair. So when my code comes here and it says, OK, I want to have the person, and if the person is then reused anywhere below, it's going to say, oh, I know where to get this person. I have this address. The person is there. I'm going to load the person. I'm going to do something with the person, whatever. Eventually, as your application runs, this person will not be needed. In fact, it's very possible that after you use this void method over here, this person will not be needed ever again in the application, that specific instance of that reference type. So what's going to happen is eventually, based on pressure, the garbage collector will come in and clear that memory because it has nothing that says, I know that this exists. So with all that said and that knowledge now in our pocket, we're going to go back to how C# deals with memory. The first thing is that the stack is where value types can be allocated. It is not where they are always being allocated, and that is the main problem we have with object. But they can be allocated there, and that is very performant for us. Local variables and method parameters, when they're value types, will be allocated there. It is extremely fast, and the reason why it's extremely fast is because it is local. You know that you have to read value in position this of the stack, use it, and then forget about it. But the most important thing about value types is that they automatically disappear from memory when they go out of scope. And when we talk about scope here, it's what we call the stack frame. So when we go out of stack frame, just a second. When we go out of that stack frame, that memory automatically disappears. It's not garbage collected, it is just removed because we know that the only thing that really needed it was that method. So completely different from garbage collection. Now, the heap is different. Reference types always get allocated there. Anything that is an object, a class, strings, they always go there. And that's the bad side of things, because it is this big pool of memory of floating objects that needs to be garbage collected. And the garbage collection process is actually pretty brutal. I know we say that C# is great because you don't have to do your own memory management. And that is cool and all. It makes it easy to write. But the drawback is that everything has to pause in your application for garbage collection to happen. So imagine you're building a game that is a first-person shooter or something, and it has to be as performant as possible in terms of frame rate. Well, if you have to garbage collect for even 1, 2, 5, 10 milliseconds, then imagine what that can do for your players. Imagine if that is a client, imagine if that is a server. It is not a great experience. So the more memory you allocate on the heap, the more garbage collection you have to do, and the more micro pauses your application will have. Now, boxed values always get allocated there, and that is because they turn into reference types. But Nick, what the hell is boxing? I promise this is a logging talk. So, what is boxing? Well, back to our original example, you have this integer over here, an integer age, and the way this will be effectively compiled to IL code, intermediate language code that C# eventually compiles to and is picked up by the CLR to run, will actually look like this. Now, you don't have to know IL. That's just, I don't know IL. That's what I copied. But what I know is that this means that take that value, allocate on the stack, value 30, and then eventually return it. And there's no heap memory involved here. However, C# has implicit conversion of value types to objects. So if you have something that is a value type, like an integer, and it is converted into an object, then what is happening here is actually boxing, the process of boxing. And you can even see that the instruction for boxing is called box. You still have that first row, which is the allocation on the stack, allocate the value 30 on the stack, but you also say box this int32 value, and then stack allocate that address to that value here. Later, what's going to happen is you're going to have to take that value out and return it as an integer. So that process is called unboxing. And as you're going to see here, it's very similar, but the opposite. So get that from the address, unbox the parameter, and then return it. That process is actually not only a heavy thing for an application to do, because you have to box and unbox something, but it is also allocating something on the heap that you will only likely need in the context of that method invocation. So eventually, you're going to build that memory pressure, go back, and garbage collected. So why is that bad? Because you're going to build up garbage in your application. And there's two things, actually, that can happen here. The first one is a ton of boxing, but the second one is a ton of strings. Again, remember, this is all about string interpolation. I know I went a bit too far, but coming back here, you're going to have more boxing, which means more heap allocations, which means more work to set and retrieve values, which means more garbage collection invocations triggered, which means more pausing to clean things up. Inconsistent performance, slower performance, more memory pressure. And in today's day and age where everything is running in containers, this type of thing can have an impact to how many containers you can run with the same VM that runs Kubernetes, or if you're using whatever Microsoft or AWS has in their native platform. Now, the second thing is actually even worse. More strings mean more heap allocations, more garbage collections, and more pausing to clean things up. However, strings are almost always way more expensive memory-wise than any other value type that can be boxed. So boxing isn't necessarily the worst thing that can happen to your application, but you guarantee it will happen if you are to use string interpolation. But I hear you in the back over there. You say, hey, Nick, string interpolation handlers introduced in C#10 actually fixed that problem. And that is certainly true. Ever since C#10, we got a very cool feature, actually, called string interpolation handlers. And we could get it because, like I said, everything that was added between, I don't know, 4, all the way to 10 or even 11 was a syntactic sugar. So you have the same experience on the front end that you write the same string, but now if you switch the compiler and you get your C#9 code and you update to C#10, your application will actually get significantly better in the memory management department, because this code, instead of being turned into a string.format, it will actually turn into a default interpolated string handler and all that. Now, what you need to know about this is that it is a struct. It is built to only be as big as the strings you're going to have as string literals need to be. And the most important thing you can have, or that you should know about, is that in this line where we have the append formatted int, that integer is passed in as a generic. And generics have this ability of they don't get boxed. So the benefit of the compiler team changing this to convert into a struct that use generics behind the scenes is that they can actually prevent boxing, giving us that good performance. But that only fixes half of the equation. The other half is actually all these strings. So imagine you have that exact message, and your login uses that message using string interpolation. And you say log.log information, yada, 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 user name Justin to whatever. Well, imagine you process 100 requests per second, and you have, how many? 5, 10 of these messages? Immediately you have 500 or 1,000 unique strings because you have GUIs that are always unique, or ages that can class with each other, or that can be, again, in a range, and God forbid you have a date in there, this gets even worse, and you generate these unique strings that are not magical. This is memory. This is bytes that you see here. And it doesn't just magically disappear, it has to be garbage collected. So if you ever dump your application that uses logging in that way, you're going to start to have tons of pressure that looks like this. In fact, if I want to visualize it, I would have something like this. Now, this is coming from a tool called .memory, where you can effectively hook it up to an application. It's made by JetBrains. I'm pretty sure it's free as well. I don't think it can run on Mac. I wanted to show you how this runs in real time. Unfortunately, I couldn't. But what you see here is how the memory pressure in your application builds up and then it's being cleaned. So we have this sort of peak happening, and this is compressed in terms of time. So the application doesn't do that all the time. But over a period of time, that's what you're going to get. And this is blue because this is a generation 0 of your garbage collection, which has multiple generations. We won't go into that. That's too much. But what you see is we have this pressure building up, and then around the point of 16 megabytes, there's the garbage collection trigger, kicks in because of pressure, and then clears it. And you can see that and say, OK, it's doing its job. But you might be missing these little fellas over there, which, it's on the bottom, so easy to miss. What is that? Well, if you can read that thing in the corner, which I'm pretty sure you can't, it says GC time. So during that time, your application is doing nothing. It doesn't process any events, any messages, any HTTP requests. It doesn't generate any frames. It doesn't do anything, but stops, says, how many reference types in the heap have no references pointing at them? Oh, all of this? OK, I'm going to just delete everything. And also, to be more efficient, I'm going to move around the existing ones in different locations that it's more convenient for, and nothing else. So you're wasting all of this memory that you could not be using, you should not be using, in fact, and you're causing a bad experience for your consumers. So rule number 2, I shall not use string interpolation or concatenation in the message template. Very, very important. Now I'm going to talk about one of the greatest things about logging, and how many of you know what structured logging is? How many of you use Serilog? The rest of you use the built-in provider? Or you're not logging? So let's talk about structured logging. Structured logging is the following. So consider that we established that, yeah, okay, string interpolation is bad, fine, but I'm not boxing, and maybe I don't handle many requests, so I don't really care. Maybe I handle 1 per second. What will 1 request per second do for me? Nothing. Fine. Now, you're logging payment details, payment ID, and the payment failed with status, whatever is coming in, and what you're generating in something like application insights, and this is from an actual application insights instance, is the following. You have payment with ID, whatever, failed with payment status, requires action, canceled, request confirmation. It can be anything. Again, many combinations, but we don't care. Not much throughput. Now, a business person walks into the room and says, hey, Nick, find all the payments that failed with status canceled. Now, I am smart. I'm saying, if a payment was failed with canceling status, then I can simply say, if the thing ends with canceled, order by timestamp and return. And I will get it. I will have all the events, and I can give them back to business. Now, 2 days later, business comes back and they say, hey, tell me what happened for payment with ID X until it was canceled. So any messages or any logs that contain payment ID, whatever. Good luck. You are not going to ever write some ridiculous regex that tries to match GUIDs, that contains payment ID. It's just not going to happen. But now let's do this. Instead of using string concatenation or interpolation, we're going to use the first parameter, the message template, as it should be used. We have the payment with ID, payment ID in brackets. Now, note here, there's no $ in the beginning. This is not string interpolation. This is just a string that my ID actually recognizes that it should be a template, and it colors these parameters. So I have a single string literal, a single string constant, and then I have the ID and the status as separate parameters. This will allow me to do the following. App Insights will still produce the exact same thing on the logging front. That doesn't change, but it actually happens there. It doesn't happen in my application. All I'm saying is I have X amount of triggers with this message template and these parameters. Take them into whatever you want. And what App Insights will do is the following. It will use them and add them in a section in the log, which you can expand, called custom dimensions. Now, log list, sec, whatever, have the exact same thing. They might call them properties, parameters, dimensions, you name it. But ultimately, that's what you get back. And as you can see, I have this original format, and then I have the payment ID and the payment status as individual values. This means that I have my fixed original format that, by the way, is only allocated once in my application, because when you have a string literal or a constant, that value on startup will be allocated on a place called the intern pool or the string intern pool, and it will have a reference, and anything that uses it will just point at this because it's the same value. This can't happen in runtime. You can force it, but it's very niche to force it. So you're going to get the performance benefit of only allocating one string for everything related to this log, but also each parameter is separate, which means that when business says, give me everything that was canceled, you can just say this. Traces where custom dimensions.payment status is this. If you want something with payment ID, anything with a specific payment ID, you can just do the same thing, and you're going to get the payment ID back. So it is very convenient. You can even use the original format to listen for specific events that have that format. And in fact, you can even use that to set up alerts. So say if something happens with a specific message, then set up an alert. If the parameter is this, that's not recommended. Alerts should be based on other things, but that's for another talk. But you could do that. Now, that other person over there said that, hey, Nick, this is still boxing. This ID and the status, this ID, yeah, this ID is a value type. This is a reference type, but because it's a string, but the ID is a value type. So it's still boxing. And the truth is, it is. But boxing one integer and allocating one string per message doesn't even come close. By the way, this sound is giving me PTSD because it's my alarm. So every time ugh. Right, so rule number 3. I shall use structured logging and give my parameters good names. And you want them to be consistent. If you want to have any luck in ever debugging the system, you want your payment ID, your payment status, your payment whatever in the context of your business to be the same in all of your logs, not only in your service, but in your system. Because you might want to correlate in different microservices if you're using microservices. But many of you raised your hand and you said, hey, Nick, I am using Serilog. Serilog used to be the only solution to do structured logging. .NET later added it, but it's an excellent library. In fact, until very recently, it was my go-to. It's fantastic. It has this concept of sinks. So all you have is a fixed abstraction of how logging should be done, and they name the bloody parameter message template. But and they have great documentation as well. And they don't pay me, sadly. But the great thing about it is that it has so many sinks. So if you have your code and what you're pushing your logs into is Logly, but in a year, another CTO comes in and they say, we need to move to Azure. I'm going to use application insights. The only thing you need to change is that sink. And that is it. Now, you can do logging with Serilog in 2 different ways. The first one is the raw Serilog iLogger. The second one is using the serilog.extensions.logging NuGet package. Both of them will produce the same results, but they will get there in a different way. The first logger, this one, which is the raw version, will actually be registered as a singleton, and you're going to use the iLogger, which is a type of Serilog. This is not the iLogger of Microsoft. This is their own iLogger, which can get very confusing if you have both in your application. This, on the other hand, still registers the Serilog logger, but it actually wires it up with the add login call in ASP.NET Core or .NET to effectively work as a provider. So in ASP.NET Core and .NET, you have the concept of login providers, and one of them can be Serilog. Another one can be application insights, but you can remove all of them and only have this. Now, why is it important? Well, it's important because if you're using the iLogger of .NET, using the right version, then you're not getting the benefit of Serilog's performance. But if you are using the raw iLogger, you are. And you do because Serilog prevents boxing by using our new best friend, generics. So instead of having this array of objects that will eventually get boxed and will cause us a lot of trouble, it will allow you to provide n amount of T parameters, I think all the way to 8 or 10. They literally made 10 different methods with generics to make it easy for us. And this will prevent boxing. But it doesn't. Dun, dun, dun. Why doesn't it do it? Let's talk about log levels. So what is a log level? A log level is inconsistent if you're using logging in Serilog. That's what it mainly is, because trace is called verbose in Serilog, debug is debug information warning error, and then Microsoft calls the critical, Serilog calls it fatal, and then Microsoft decided that none should go as the end, and then if they add another one, what is after none? What the hell? Like, just put it in 0. Anyway, so what this allows us to do is to define a minimum threshold for something that is allowed or should be logged. So any application in ASP.NET Core, ever in .NET Core, has something like this in the app settings. If you go and create a new one, you're going to see it. And the idea is pretty simple. For anything outside of the namespace of Microsoft.ASP.NET Core, log it from information and up. And it is sort of, you have to read from here and up. So if it is information, it's inclusive. If it's information, if it is warning, if it is error, if it's critical, then this default will log it. Now, if you logged everything in Microsoft.ASP.NET Core that is information, you would, and you're using something like Datadog, so you're paying for your login provider, you'll be bankrupt because it's logging everything. Now, if you set it to debug, I'm sorry. So What this allows you to do is say, OK, I don't care about debug, I don't care about trace, I don't care about verbose. All I care about is information, warning, error critical. Cool. But you can define different ones for different purposes, which means that the Microsoft logger looks like this. You have your parameters up there as an object array, which we define is going to box your application, your parameters, if they're value types. And then there's an is-enabled check within the log method, which at that point, we've already boxed that parameter. So we're preventing the logging, but we did something we could technically prevent, which kind of sucks. We could fix this. And Serilog does fix it. And it actually has a very nice comment as well on why Serilog fixes it. So Serilog will have this write method eventually that uses those generics that we mentioned, and we said that it won't box, but it also has an is-enabled check for the log level inside its method. Eventually, it is going to box, because you have to pass the parameters somehow. So eventually, we're going to box. But if you have debug, or log debug, or log verbose, or log information, or anything, any of those values won't even do anything to your performance because we're using generics. It's a very nice approach, and it's one of the biggest selling points of Serilog. Now, let's say we have this method, which is using the ASP.NET Core or the .NET login provider, and we're doing things properly. What we can do to prevent logging in our application is we can do something like this, where we have the iLogger is enabled, log information because I'm logging information below, and say return early. And this will allow us to emulate similar behavior. Now, this can get tedious, but it's only as tedious as the work it is preventing. So it's a maybe pick your battles here. Now, we'll see why you won't really need to do that manually, but for now, know that you should prevent unnecessary boxing for inactive log levels. It can really make a difference. But the great thing about .NET in general and logging is the .NET team has been hard at work. And one of the greatest features, and maybe most underrated features they have shipped, at least underrated for the outside world, is actually source generators. So I think in .NET 5, if I'm not wrong, we got the first flavor of source generators. And the biggest problem with them is that the developer experience, if you don't work for Microsoft, sucks. And the developer experience, if you do work for Microsoft, sucks, but you know what you're doing. So that's the difference. But they're trying to fix it. They're hard at work. But one of the source generators we got now and we have built in at .NET is the logging source generator. So what you can have now, which is fantastic, is you can have a static partial method. In this case, it's a void. You can decorate it with the logger message attribute, and then I can define my information log level, my message template, which they still named message. You had a chance to fix it, but you chose to be consistent instead, even though you're consistently wrong, John. And what this will do is it will add an extension method on the iLogger, which then you can go ahead and use just like that. So if you want to log a payment error or a warning, you can pass down ID and status. And because it is a method, you don't even have generics, which, by the way, do have some overhead, but no memory implications. It will be a compile time call to that log method. And what this will produce on the end, the app inside front, it's actually this. It's the same thing as before. It will use the original format, payment ID, and payment status. But why is this awesome? Well, it is awesome because that's what it's going to build for you behind the scenes. It looks way more bloated, actually. I just cleaned it up a bit. But fundamentally, that's what you get. And why is it amazing? It's amazing because, first, no generics, no boxing. You have the parameters, compile time. Awesome. The next thing is that the first thing it's doing is the logger is enabled. Is it enabled? Yes. We're going to go in. Is it not enabled? No. So sort of Microsoft and, the source generator acknowledges that this is something you should be doing. Yes, it is tedious to do manually every time, but if you want the best experience, you should have it. And this is something you can't really remove. You can customize some things, but this check can't be removed. So it is needed. Then you have this call over here to this method called log callback, which isn't really a method. If you are very careful, you're going to see that it is actually a cached static read-only action, which accepts an iLogger, GUID, and string, and accepts a nullable exception if an exception is thrown and you want to log it. So being cached, it is very performant. Now, what you will see here is that this is using the message or logger message.define method. Yes, generics are used, minor impact, but if we look into that method, the define method, you will see that it's tailor-made for the parameters we have. So we have this log values formatter, which is a struct, and then the log values, which are structs. So there's no boxing happening here. We have this callback, which is cached, so it's optimized as well. And then it will prevent to double-check the log level by allowing you to skip the enable check, which if we go back, you're going to see that is true by default. I did not change it. You can override it, but the use cases where you want to override it are actually really niche. Don't touch it. So what you get is a very performant source generator, which minimizes all the overhead that it can, and it's actually way more performant than Serilog as well. Source generators in logging are the best case scenario. So rule number 5, you should consider using source-generated loggers. It can be a bit of a pain to maintain because they are extensions on the iLogger, but you can sort of customize it and optimize it for your own workflow. So if you put some effort in, you can get a very clean result. Now, I want to talk about custom string interpolation handlers because one of the comments I get about this is that, well, yeah, we can use a template, but actually, since C#10, you can have custom string interpolation handlers. So this comes out of the box, and it's the default behavior, but you can actually write your own. And it's very easy and sort of dumb to write your own. It looks like this. It's duck typing in C#. When there's duck typing involved in C#, you know that you should not be doing it. It's made for the C# compiler team. But you can. So we can make a ref struct guaranteed to be allocated on the stack because you won't be allowed to do it on the heap. And I think that's a ref and not a read-only. I could be wrong on this. And all you need to do is slap an interpolated string handler on this type, and then you can use an inner handler. So you can write your own append formatted method, which, if you remember, it was being auto-generated all the way back here, append formatted with a generic. You can write your own. And what you can do is use another great C#10 feature. C#10 is fantastic, by the way, great release, which allows you to capture, if you can see here, it's very weird, but you can actually capture the name of the parameter that is being passed in the string interpolating handler. So, and what I'm doing here is, if you see, I'm adding my own curly braces. What does that mean? It means that I can have something like this, and this looks like a ref some method, but actually what you pass down is an interpolated string, which means that for you, the experience is this. That's exactly what you will be doing, what you were doing before, but behind the scenes, that's what you get. So you actually have an original format with proper templating. So this will only allocate one string for the whole application's lifetime. And you have parameters like ID and status, all by doing this. It can be a bit confusing to demonstrate, but it is extremely powerful. But with great power comes great responsibility. Because when you capture values like this in compile time, it means you can capture values like this in compile time. And this will actually go as parameter names in app insights. Like you would see them here. So what you want to do is actually not get too clever with yourself. You want to be able to have consistent service-wide, system-wide parameter names. This approach can be very powerful. I have to agree, it's very elegant, very powerful, but it is very abstract. It is not obvious. Nothing confirms that someone won't go there one day and refactor the ID name and change it to GUID or payment ID, which will mess up all of your logs and create inconsistencies. And technically, you could write a source generator that guarantees that, not source generator, a source, the thing that checks your code at compile time to give you a warning. Analyzer, you can write an analyzer, thank you, but don't, just don't. So, rule number 6, just don't try to get too clever with the tooling. You can get into traps that you should not be dealing with. Now, before I give you rule number 7, I want to stop for a second, because many of you who are watching this, I'm sure, will think that this is actually premature optimization. I made it very clear that it is not. But that's not enough of an excuse. Like what Nick said, it's not premature optimization. Great. Let's trust him. What does he know? Have you heard this phrase before? Premature optimization is the root of all evil? So I believe the root of all evil is the phrase premature optimization is the root of all evil. Because even though in context it can be right, I think many people throw it around as an excuse to write bad code. Not even non-performant code, but as a get-out-of-jail-free card. Like, well, we're not processing 1,000 requests per second, so I'm not going to write good code. And it should not be like this. So nothing that you've seen here has to do with this. We did not optimize to have better logging. We wanted to do logging correctly, and we got some context on why doing it correctly also optimized it. Logging is a cross-cutting concern. It is on the API level, it is on your domain, it is in your database, it is everywhere. Cross-cutting concerns should be performant. If they're not, the whole system is not performant. Like I said, one of the main things that was optimized in .NET was this. So please, if you are to use this phrase, even in your jobs in general, try to contextualize it, because performance is contextual. It doesn't mean for me what it means for you. But try to not use it as an excuse, because it shouldn't be. I just want to wrap this up with answering a question, which is, why do we log? Right? You might say we log so when things break, we know how to fix them or how they broke. Or you might say we log because, I don't know, that's what the industry is doing and I have to. But the way I like to think about this is that we are logging because we want to tell a story. We want to tell a good story. It is the story of what happened to the request or whatever you're processing. And the good story is powerful. Now, there are books, and then there are good books. Do you notice something? The realistic usable outcome of these two books is the same. But look at the first one. I mean, they're both JavaScript, so it's a losing game. But at least you get the gist with the thing on the right. The thing on the right is what my grandpa would call laconic. Now, I guarantee that no one in this room knows what laconic means, and if it does, it's probably Greek. You're Greek, I know. You're Greek? Yeah, okay.
It's in Romanian as well.
Cool. It's not Romanian, it's Greek. It comes from a place in Greece called Laconia, and the capital of Laconia is Sparta. So, Spartans, not this one, no, these ones. So Spartans are known for being laconic. What does laconic mean? It means using very few words to express what you mean. It doesn't mean, it's not intentionally bad. It is not meant to intentionally hide stuff from you. It is meant to not waste your time because the time was allocated in training and being warriors. And that's the way I like to think about logging. You want your logging approach to be laconic. You want to be accurate, descriptive, and have short messages. You want system consistent parameter names, not just application, not just method. If you name something payment ID here, all the way down in a different country, if your team is distributed, they should be using the exact same parameter name, exactly spelled. You want to properly utilize your log levels. Does this really need to be a log information? Really? What will this thing being log information help you to define the story or describe the story? I'll rephrase. How many of you use information as your minimum log level for your applications? Really? How have you ever said, oh, things are going great, I want to see how things are going great? Never, never. And what you end up with is this bloat in your login provider, which, by the way, you pay. I've used Datadog. We gave a kidney away to pay for March. It can get really bad, and you're encouraged to not log the good path. You want to log warning and upwards, in most cases anyway. And if you are to use information as a log level, the minimum log level, you want to be very, very careful. It is not meant to be abused. There's 3 pillars in telemetry: logs, metrics, and traces. And if you're using OpenTelemetry, you would know. So to wrap this up, only log what's necessary to tell a good story. Thank you very much, and keep coding.